This is Midday Sunday. We are talking about the Kepler mission, which has discovered Kepler-452b, or Bravo, as we would say, which is a planet a lot like ours.
It's a lot like ours. It's one of over 1,000 planets that the Kepler mission has discovered and confirmed. And Kepler-452b is very close to being a slightly chunkier elder cousin to our own Earth.
There's another artist's rendition that shows all of the exoplanets that are out there, or at least the ones that we know of. In addition to the question of is there other life out there, at some point humankind on Earth is going to have to evacuate the planet because our sun is going to fade away. Is this another reason to be looking for places like this?
It's a long-term problem. I wouldn't have anybody lose a lot of sleep over that one. But the first place we could go would be to Mars. If we've totally messed up the Earth, Mars is a not bad place to escape to. Big comet or an asteroid on a collision course with Earth. Let's go start Earth 2.0 on Mars. Once we get to a problem with the entire solar system, we have a big problem. We have to be able to go escape our sun and go someplace else, and that's the technology that we hope they invent in the future before we have that problem.
Yeah, there's some of the exoplanets. How much longer is our sun going to continue to?
We've got another 4 or 5 billion years to go. Okay. It's not high on your list of concerns.
Is anyone looking at ways to go beyond the speed limit of 186,000 miles per second?
The speed of light is not only a good idea, it's the law. And it's really hard to come up with a way using any physics that we know, and this is physics we know pretty well, to beat that speed limit. If you look at movies like Interstellar or something where people say, well, you go into a black hole and you cut the distance you're going to, down to a much smaller distance by going through a wormhole or something like that, maybe you can do it, but it'd probably kill you to get there. So we're stuck in our little solar neighborhood unless someone comes up with a really good invention.
Pluto, big discovery, the arrival of the New Horizons.
New Horizons was launched in 2006. A very patient and dedicated science team waited for their moment of glory, and New Horizons has just come up trumps.
So even though you're involved over here in the Kepler project, I would imagine that Pluto raises your pulse level a little bit.
Oh, absolutely. And Pluto is one of the last unexplored places in our own solar system. It's the first of what we would call a minor or dwarf planet. It's one of the leading members of objects in what we call the Kuiper Belt. It's sort of a whole army of sort of 1,000, 2,000, maybe 1,500 mile diameter icy bodies that were really the building blocks of objects in our inner solar system, and they're just littered out there like, kids' toys way outside the room. And Pluto's the biggest, but there are others out there. They're cold, they're icy, and New Horizons gave us our first look, and it's spectacular.
Yeah, and some of these images here, and there are many more to come.
Many, many more to come. The disadvantage of New Horizons is it's way far out there now. It's something like 40 times the Earth-Sun distance, so it's sending its signals back very slowly. If you remember the early days of dialing up your computer to connect to the internet, this is the slowest internet connection in the solar system, just about. So it's going to take them 1.5 years to send back all their data. So the images come back compressed, slowly, but as NASA gets the images and the New Horizons team looks at them, they'll be releasing a steady stream of data about Pluto and its moon Charon.
These devices like New Horizons and I guess maybe Voyager and some of these others, they just keep on going.
They're just going. We found the New Horizons team using observations from the Keck telescope in Hawaii and the Hubble Space Telescope found another much smaller Kuiper Belt object that they're now going to go off and explore. They'll get there in I'm not sure how many years, another 5, 10 years. So they'll go close to that, take some pictures, and then just keep on going.
Do we have any notion at this point how long we will be able to continue to receive images from these devices?
Voyager's been going for many, many years, and again, the signal strength gets weaker and weaker and weaker. Both the power on the spacecraft starts to drop with time, and the distances get bigger, but Voyager's been going for almost 50 years. We're still getting data from it. And New Horizons the same way. The data rates will get slower, but once these things are built and operate, they take a licking and keep on ticking.
I know you're the executive director of this particular project, but if you were running everything, where would the place be that we should be going to that we aren't going to yet? Where would you like to see us go?
To actually go, I think Mars is enormously exciting. Europa and Titan.
Europa?
Europa and Titan are moons of Jupiter and Saturn, respectively.
Okay.
And they're very interesting in their own way. Europa is one of these ice worlds, but it looks as though things have cratered into it and sent up splashes of liquid that's then frozen again. But we could study that liquid and see what's going on in the oceans that are probably the major constituent of Europa. Titan's further out, it's colder, but it has a very thick atmosphere of things like ethane and methane and so on. It has oceans of hydrocarbons. If you brought it in close, it might well be a habitable world. So these would be things to study in our own solar system. Mars, of course, in the end, is probably the most important. We've studied it a lot, but it has more surface area that's available to explore than does the Earth, because, of course, most of the Earth's surface is underwater.
Yeah, exactly.
So going down into caves on Mars, it'll get warmer, you might find running water. There's a whole world to explore on Mars.
When you were growing up in New York, you were a kid, were you interested in astronomy then?
Oh yeah, I grew up 4 or 5 blocks away from the Hayden Planetarium, now the Rose Planetarium.
Forgive me for interrupting, but the dreams that you had as a kid, how do they compare with the reality that you have as a doctor, as an adult?
There's no jetpacks, no flying cars, but in terms of the science, it's beyond what we could have imagined how well we're doing. And it's really the technology of the instruments we have. It's putting those instruments onto telescopes above the Earth's atmosphere, putting them in space, that has really enabled a revolution in astronomy overall, and certainly in the area of exoplanets.
Very quickly before we break, tell me one time when you've discovered something or learned of something and said to yourself, golly.
We first put up an infrared satellite called the Infrared Astronomy Satellite back in the 80s, and there for the first time we started to find suns like our own sun in the process of formation. The first proto-suns. Now we're finding planets around nearby stars. It's a fantastic evolution.
We'll be right back. Stay with us. When we come back, more information about how you can get more information. We'll be here in just a couple of minutes.